Okay, today's lesson we're going to look at isosceles and equilateral triangles. Again, if I go too fast in this lesson, the link for this lesson will be located on Schoology, so you can watch it again as needed, as many times as needed. First of all, we need to identify the parts of an isosceles triangle, and while all the normal traditional parts for a triangle still apply, sides, vertices, and interior angles, there are actual special names for parts of isosceles triangles because they behave differently. So an isosceles triangle, if you recall, is a triangle with at least two sides that are congruent. So let's say CD and BD are the sides that are congruent. We would call those sides then the legs. So the legs are the congruent sides of the triangle. And then the other part that is not, the other side that is not congruent is what we refer to as the base. So you'll notice that the base is not necessarily at the bottom of the triangle, it's on the side here. Base just means it's the non-congruent side. On either sides of the base, you'll find two angles. So angle C and angle B are known as the base angles. Those are called the base angles. So you can identify them by first finding the base, and then on either end of the base is a vertex for a base angle. And then angle D is called the vertex angle. Alright, so those are the special parts for an isosceles triangle. In fact, what you may have recalled from a previous geometry lesson in other classes is that base angles of an isosceles triangle are congruent. So this angle G right here is the same size as angle F. So base angles theorem says that base angles of an isosceles triangle are congruent. All right. Easy way to spot the base angles, they are located opposite from the congruent sides. So if you can find your two congruent legs in your isosceles triangle, located opposite from those are your congruent base angles. Another way, of course, is identify where the base is. There's the base. So on either end of the base, you'll find a base angle. Base angles are congruent. Okay, we are going to look at what's called a converse statement next. A converse statement is, let's say you have a statement that is formed by if and then. So I could rewrite the theorem we just wrote as an if-then statement. If a triangle is isosceles, then the base angles are congruent. That's an if-then statement. And that's actually the proper way to write a theorem, is in if-then form. So you have the word if followed by a hypothesis or something that has to be true, so that then can be followed by a conclusion, something that will be true if the hypothesis is true. So if it's true that you have an isosceles triangle, then it's also true that the base angles are congruent. A converse statement is when you switch the hypothesis and conclusion. And we are using the word hypothesis different from the way we use it in science class. The hypothesis in math class is the stuff that follows if. Alright, so if I wanted to form the converse of the base angles theorem, then I'm taking all of this right here, which is the hypothesis, and I'm switching it with this right here, which is the conclusion. So the new statement says, if base angles of a triangle are congruent, then the triangle is isosceles. So basically, and this is a true statement, by the way, not all converse statements are true statements, but this one is true. So basically this one is saying if you have a triangle and all you know is that these two angles are congruent, that's enough information to be sure you're looking at an isosceles triangle. That's what the converse is telling us. Okay. Next, we're going to look at a proof to discover a new fact about equilateral triangles. So if you recall, equilateral triangles are all three sides of the triangle are congruent. And that's what we're going to start out with. We're going to start out with the fact that ABC is an equilateral triangle that's given to us. And let's just focus on two of those sides being congruent. Let's say we'll focus on AB being congruent to AC. Because that is true, we know that the triangle is also isosceles, because isosceles says at least two congruent sides. So we can say that triangle ABC is isosceles, and in this case, BC is the base. We're basing that on the definition of what it means to be isosceles. I know some of you might be confused. I thought this was equilateral. So an equilateral triangle is a special case of an isosceles triangle, because three sides being congruent is at least two sides being congruent. All right, if you know that you can classify it as isosceles, then you can say something about some of the angles. So in this case, I can say that the measure of angle B is equal to the measure of angle C, and that is based on the base angles theorem that we just learned. All right, I'm going to do this whole process again, but focus on two different sides. So maybe this time we focus on AC being congruent to BC. Now this time we're going to say that AB is the base. Again, based on the definition of isosceles. All right, if I'm focusing on AB as the base, then B and A are my base angles. So the measure of angle A is equal to the measure of angle B. And that again is the base angles theorem. Okay, now we should be able to make a concluding statement based on this one and this one. If A is the same as B and B is the same as C, then it follows that the measure of angle A is equal to the measure of C also. And that's by the transitive property. So let's write that all in the last picture. First we knew B was the same as C, then we knew A was the same as B, and now A is the same as C. So they are all in fact the same size angles. So the question remains, what new fact did we just prove? We just proved that if you know a triangle is equilateral, all the sides are the same, then it's safe to assume that the angles are all the same. And we have a word for that. It's equiangular. So we just proved that equilateral implies that the triangle is also equiangular. And you should know what the measure of all those angles are, because you know the sum of all the angles in a triangle is always 180. So if they all had to be the same, they would be 60, 60, and 60, because that's what adds up to 180 degrees. All right, let's practice with these theorems a little bit here. So that's going to be the start of the next video.